Scene 3, take 1.
And Kevin, your payment. Quick, camera's rolling. Thank you. So some vocab coming: exterior angle of a polygon and remote interior angles. So make sure you add these to your notes. I'd recommend getting a screenshot of this diagram too. I think this picture is worth a lot of words. And it gives you an example of exterior and also the related remote interior angles. The definition, though, of an exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. Angle 1 is an example of an exterior angle, and it's formed by taking this existing side of the triangle and then extending this side of the triangle. So that's an exterior angle of a triangle, and it's the same is true for any polygon. And then we have remote interior angles. So I'll read about those and then we'll look at the example. For each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. So if you think about the word remote, it can mean from afar or from a long ways away. A remote control for your TV, you can control it from your couch. So these are the remote interior angles. That helps me identify them. They're the ones that are the farthest away from the exterior angle. So relative to angle 1, angles 2 and 3 are the remote interior angles. The theorem below states the relationship between an exterior angle and its two remote interior angles. Again, you should take a screenshot of this. Theorem 3-12, nicknamed the triangle exterior angle theorem. It states the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. It seems like a mouthful when I read the whole sentence, a lot of vocab, but what it's just telling us is that if we add the measures of the two remote interior angles, that will equal the measure of the exterior angle. You can use the triangle exterior angle theorem to find angle measures. Problem 2, using the triangle exterior angle theorem. A says, what is the measure of angle 1? Well, just practice using what we just learned. Here is our exterior angle, angle 1, that we're asked to find the measure of. And then we identify our remote interior angles, having measures of 80 degrees and 18 degrees. And so we just add those together. So the measure of angle 1 equals 98. B says, what is the measure of angle 2? So again, an application of the triangle exterior angle theorem. This time we're given the exterior angles measure. We know one of the remote interior angles measures, and our job is to find the second. So in this case, we set up an equation and solve for the measure of angle 2, and it turns out it equals 65. Okay, your turn. Two angles of a triangle measure 53. What is the measure of an exterior angle at each vertex of the triangle? And I'm going to help you out with a diagram here. Remember, it's often useful to sketch the situation and label all the information you know. It says two angles of a triangle measure 53. So I've just sketched an arbitrary triangle. It kind of looks like an equilateral triangle, but that's not important. Two of the angles measure 53. And we're asked, what is the measure of an exterior angle at each vertex? So now we have to imagine exterior angles at each of these vertices. And our job is to identify the measurements at each of these. So we can use the remote interior angles theorem. We may also be able to use the fact that this angle and this angle form a linear pair. Same with this angle and this angle. But there's a bit of a question mark in this area. But you can use what we've learned in this section to identify the measurement of this angle, and that should help you identify the measurement of this angle. So you're going to end up with 3 different angles measures. Just make sure that you choose the option that has those same 3 listed.